Good day to you. This is teacher Leland Alejandro, and we're going to discuss figures and the coordinate plane. So we will be using triangles and quadrilaterals as examples. So the contents of the problems will be about finding perimeters and proving some given conditions. So let us see the problem set on the other screen. Okay, this is the figures in the coordinate plane lecture examples. So we're going to have eight worded problems with diagrams. Let us solve the first one. Okay, here's the first one. Solve the following figures in the coordinate plane. Number one, the vertices of the parallelogram are A, 4, 4, B, 6, negative 2, C, negative 4, negative 4, and D, negative 6, 2. Find the point of intersection M. So we're after the point of intersection of the diagonals. So we're after the coordinates of the intersection of the diagonals. Now let us see where the diagonal is, and let's do some annotation. Now to show you where the diagonal, we shall connect this corner to the other opposite angle there, okay, and the other one to the other one there. Okay, by graphical solution, you can see that the two diagonals intersect at the point of origin 0, 0. Okay, so you can very well see the point of intersection M, X, Y, and this is located at 0, 0. So this is the required answer, and this can be found by diagrams. Just draw the diagonals and you'll be able to solve graphically the 0, 0 point of intersection of the diagonals. Now, there's another way. You can actually put the labels. We have the 4, 4. We can use the letters, the capital letters. We have here A, 4, 4. So this must be the A. There. And we have the 6, negative 2. That should be at the fourth quadrant. This must be the B. There. And we have the next, negative 4, negative 4 at the third quadrant. This must be the C. There, the point C there. And we also have the coordinate of the point D, negative 6, 2, which is located over here. There. And so we were able to locate those points. And for the distance AC, we can actually obtain the midpoint by the midpoint formula. So for considering the point A and the point C, we can actually determine the midpoint using the given A, which is 4, 4, and the C, which is negative 4, negative 4. There. Okay, the midpoint formula is actually X is equal to X of A. That means the X coordinate of A added to X coordinate of C divided by 2. And the Y, you can make use of the Y, which is Y of A plus Y of C, point C, divided by 2. And we can make use of the numbers. Here is X is equal to X of A. X of A is the 4. And then X of C is the one over here, which is negative 4. So plus a negative 4. And then we divide by 2. So finding the average of 0 will still be 0. And we have the X coordinate of the point M. How about the Y coordinate of point M? So we will be using Y, and this is Y of A. Y of A is the 4. plus y of point C, which is over here, it's another -4. And then we divide this by 2. And you see, this will still be 0 divided by 2. And that means this is 0. And we were able to determine the coordinate of point M, which is the same. That's 0, 0. So you can use computation or you can use graphical solution. Whichever you use, you will be able to find 0, 0. And that's the answer for first number, the point of intersection of the diagonals. Okay, so this goes to our number 1. Let's continue with number 2. Let me clear the screen. Let's proceed to the second number. Here's the second number. Okay, for the second number, figure RSTU is a parallelogram with vertices at R, -6, 7. So where is R? It must be this. There. And then point S is 6, 3. So that should be at the first quadrant. So this must be the point S. And we have point T, that's 4, -3. That looks like at the fourth quadrant. So that is actually this point here. So this is point T. And then the fourth point U, it's -8, 1. That should be at the second quadrant. And it's over here. So this must be the point U there. Okay. So this is -8, 1 coordinate. Those are the coordinates of point U. Okay, so we're asked to prove that it is a rectangle. Okay, so how do you prove that it is a rectangle? First, we will have to show that the corners are at right angles, or yes, 90 degrees. The corners or the vertices are 90 degrees. Okay, so we can use slopes here. So if we're going to use the slope formula, okay, then we will be able to find the slope of RS, okay? The slope of RS. So we can find M of RS there, okay? This line here. What is the slope of this segment, okay? What is the slope of this? Now, using the given point R, we have the point R, and this is -6, 7, and the point S is 6, 3. Okay, the point S, that's 6, 3 there. Okay, so if we're going to make use of the slopes, and we will get the difference of the Y values divided by the X values there, then we'll be able to get the slope of segment RS, or that particular side. Okay, so we can try 7 minus 3, and then -6 minus 6. There. This is how to get the slope. Okay, difference in Y divided by difference in X. And we're going to have something like this will be 4. This will be -12. And we can reduce this to some lowest term. By 4, this is 1. By 4, this is 3. Still a negative slope there. Okay, we have a negative slope. Now, let us determine the other slope of the other side, say ST. Let's consider the slope of this ST. Okay, ST side. So we will call this M for slope and ST. There. Okay. Now we will be needing now the point T. Okay, we'll be needing the point T. Okay, the point T has the coordinates 4, -3 there. And then again, to find the slope, difference in Y divided by difference in x. There. So we shall have that, and that'll be 3 minus negative 3 divided by 6 minus 4. Okay, so 6 minus 4. And this will give us 3 plus 3, which is 6, because that's 3 minus negative, that becomes 3 plus 3. So that becomes 6. And then at the denominator, we have 6 minus 4, which is 2. And we have 3 there. Okay, all right. So by comparing now the slopes of segment RS and segment ST, you will notice the slopes are negative reciprocal of each other. Okay, negative reciprocal. The first slope RS is negative. Okay, and the second slope is positive. Okay, also the first slope is 1 over 3, and the second slope is 3 or 3 over 1. Okay, so they are negative reciprocals of each other, and so this is 90. This corner is 90. Okay, all right, so we were able to prove that that particular vertex or corner is at right angles to each other. Okay, now we shall see the slope of RU. Okay, the slope of RU, and then compare it to RS. All right, let's solve the slope of RU. Okay, we will be needing R, point R, and point U. All right, so let us just erase some of our computations here. And we will be needing R. Okay, so R is over here. All right, so let me just put the point U. Here is point U. And point U coordinate is negative 8, 1. Okay, again, to compute the slope of RU, we will have to make use of the difference in y over here, 7 and 1, and divided by the difference of x, the negative 6 and negative 8. Okay, all right, let's get the difference 7 minus 1 divided by negative 6 minus the negative 8. And we shall have 6 divided by positive 2. Okay, because this will become negative 6 plus 8. So therefore, that's a positive 2. Okay, that's a positive 2 there. Okay, all right. So let me just clear those. All right, and then 6 divided by 2 is, again, this is 3. This is 3 there. That means we can now compare the slope of RU and the slope RS. Okay, these two here. All right, so what do we have? The slope of RS is, again, negative reciprocal of the slope of RU. That means this segment here is also at right angles with RS. Okay, this will be another 90 degrees. Okay, all right. How about the fourth side? Okay, which is TU. Okay, let's put the T. I think we erased that. There's a letter T here. There. Okay, there must be a letter T there. All right, let's determine the slope of the fourth side. Okay, we will call it slope TU. Okay, let's call it slope TU. And then we'll make use of the point T and point U. Okay, all right, let's remove the point R first. Let's remove this over here, and then we shall use the point T. Our point T has the coordinates 4, negative 3. 4 and negative 3 there. And now we shall get the difference of y. That means 1 minus negative 3. 1 minus negative 3 divided by, of course, difference in x. That's negative 8 minus 4. -8 minus 4. All right, we shall continue. This becomes 1 minus minus, that becomes plus. So this will become a plus 3. So 1 plus 3, that's 4. And then at the denominator, you have -8, -4, that's a -12. And again, this will be reduced to some lowest term, -1/3. There. Okay. So that means the fourth side, this side here, all right, this particular side here has the same slope as RS. Okay. They are parallel. Okay. Also, RU and ST are also parallel. Okay. All right. Let us now compare the relationships of RU and TU. Okay. All right. RU and TU. Of course, that will be this portion here. RU and TU. And they are also negative reciprocals to each other. Okay. RU and TU. And that means this is also 90 there. And then going back to segment ST, that's 3, and compare that with segment TU, the slopes are negative reciprocals of each other too. And so this is also at right angles. And you see all the four corners are 90 degrees. Okay, they are all 90 degrees. Okay, because the segments are perpendicular to each other. Okay, RS is perpendicular to ST, ST is perpendicular to TU, TU is perpendicular to RU. Okay, and so all the corners are 90 degrees. Okay, perpendicular uh, segments, and so all the vertices are 90 degrees. So therefore, this is a rectangle. Okay, it's a rectangle. Okay, all right. So this is how to prove, and we were able to show that the corners are 90 degrees because they are perpendicular segments. Okay, now we can verify the answers. Let me just clear. Let me make the question smaller so it can be displayed. Okay, by shrinking it. Okay, let us shrink it if it's possible. Okay, all right. Now let us try to display the answer there. Okay, angle R is 90, angle S is 90, angle T is 90, angle U is also 90. Okay, that's the answer. Okay, all right. So that's the way to prove it. Okay, all right. Use the slopes, and then therefore it will be displayed that the slopes are negative reciprocals of each other. Therefore, the line segments are perpendicular to each other, and they form right angles, and right angles measures 90 degrees. Okay, so all the angles R, S, T, U are 90 degrees. Okay, all right. So now if we did not shrink it, okay, those 90 degrees will be displayed over here. Okay, see, and you won't be able to see it because our writings are directly on the answers. Okay, so that's why we shrinked it there, so you'll be able to see it clearly. Okay, over here, you'll be able to see it over here. There's the answer there. Okay, all right, so that's it. This is how to show or prove that the figure is a rectangle. Just use the slopes. Okay, all right. So let's proceed to the next number. This will be number 4. Let me clear the screen and the answer and proceed to number 4. Okay, here's number 4. We can enlarge it a little bit. Okay, over here. For number 4, for the figure ABCD with vertices at A, 5, 7. All right, where is point A, 5, 7? All right, that should be the first quadrant. Let's put it there. This will be A, and then the coordinates are 5 and 7 there. Okay, what else? We have point B, 0, -4. So that should be about the point along the y-axis. So this is B, and this is 0, -4 there. And then where is point C, -5, -3? The coordinates are both negatives, and that means this is located at the third quadrant. So that should be the one over here. This must be a point C. Okay, so let me rewrite it once more. This is point C, and this is -5 and -3 there. Okay, -5, -3. All right, how about the fourth and final point? -6, 2. It must be the last one. So this is point D and -6, +2 there at the second quadrant there. -x and +y. All right, these are the coordinates and these are the names A, B, C, D of the corner points. The requirement is prove that it is a kite. Okay, prove that it is a kite. Now, what's the nature of a kite? Well, let's draw a simple kite here. All right. Now, for the definition of the kite, for the definition of the kite, one pair has equal measurement. Okay, say this pair has equal measurements. Now, the other pair will have to be different in measure, but also they are equal. There. This is the very nature of a kite. All right. Now, what's this characteristic of the kite? This and this are equal. Okay. And this are equal. Okay. So one pair equal, the other pair also equal. But these two measurements are not equal. Okay. So this is not equal to this. Okay. So this is the very nature of the kite. All right, so let us solve and prove. Okay, let's prove the figure. Okay, that it is a kite. All right, so how are we going to prove this figure is a kite? Of course, we can do measurements, and then if one pair equal and the other pair equal, then it's a kite. And the two numbers should be different. Okay, one should be larger than the other. All right, so from the drawing, obviously you can see the side AD or DA, okay, whichever name we choose, looks like AD is equal to AB. Okay, so but let's find out. Okay, all right, so we shall compute the distance AD. Okay, let's compute. All right, so we shall use distances. Okay, use distances. So use distances there. All right, we shall try to determine AD, and this is equivalent to making use of the points. Okay, making use of the points. So from A, we have the point A. Let's start there. Okay, let's have the given first. The given point is 5, 7. And then the other one, which is D, this is -6, 2. There, okay? All right. Now, the formula will be involving the square root. So let's have the square root like this. And then the formula will be something like x of A minus x of D. Okay, so let's try writing the formula. X of A minus x of D, and then we shall square this later. Okay, and we have y of a minus y of d, like this, okay? And then we shall square the differences. So we will have a number 2 here and number 2 over there, okay? This will be the formula, okay? X of a minus xd squared plus y of a minus yd squared. All right, so let us use the numbers. We have AD distance. This is equal to the square root of, let me write the square root there. This will now be something like this. And let's do a shortcut with the numbers. X of A is 5. X of D is negative 6. So therefore, the difference is 5 minus negative 6. Okay, so it will be something like, all right, let's put it there. That would be 5 minus negative 6. And then we're going to square that. We're going to square that. So we'll be putting a number 2 here. And then we continue with the plus. And then with the parentheses. This time we'll be using y of A minus y of D. Okay, so y of A is 7 and y of D is 2. So we will have 7 minus 2. 7 minus 2 and then squared. So this must be squared there. So we put the number 2 as exponent. Now 5 minus minus 6, that will become plus. So we're going to have there 11. Okay, so if we continue with the solution, AD is equal to a square root. We shall have here another square root. And we have something like 11 squared. So this will be 11 squared. Put the number 2 here. And then plus, this will now be 5. Okay. And then 5 squared. Okay. So we put here 2 there. Okay. All right. So we have 11 squared, that's 121. Then 5 squared is 25. So we shall continue with AD. This will now be AD is equal to square root and we have 121 plus 25, okay? 121 plus 25. The square of 11 and the square of 5. And that gives us 146. So AD, we have AD, which is equal to square root of 146. There. So this is now the square root of 146 there, okay? And this will be the length AD, okay? The length AD. All right, so we have the length of AD and we can just write it down, all right? So we shall write it above, okay? Let's put it here. So our computed data is AD and this is equal to square root of 146. Let's put it here. There. And this will be a square root of 146 there. Okay. All right. So we have one distance. Okay. And this square root of 146 is this. AD is from here going there. Okay. I marked it red. All right. Now, let's determine AB. Okay. Let's use AB. All right. So let me clear this and solve AB. All right. Let's just clear this. All right. We're done with AD. All right. We're now going to do AB. All right. So let's plot and get the given again. Let's write the points first. All right. So we have here 5, 7. And then we have the other point, which is B. Does have a coordinate 0, negative 4. There. Okay. All right. So we will take note of XA and XB. And then YA and YB. All right, so we shall compute distances again. Okay, so using distances again, so we will be using distances again. All right, so let us start with the formula for finding AB. Okay, all right, so this will be AB is equal to the square root. Let us do the square root again. This will now be, okay, something like this. And then we shall have x of A. X of A minus x of B. And then we shall square this. We shall square this like that. And then plus, we will use now the y, okay? Y of A minus y of B, and then square it again. Square it also. All right, there. Okay, so this will be the formula. Let's continue with AB. We have here AB distance is equal to square root and then what is XA minus XB? XA minus XB is 5 minus 0. Okay, 5 minus 0, and then we shall square that. So this is 5 minus 0 and squared. There. And then we continue with plus. We shall now have y of A minus y of B. That will be 7 minus negative 4. There. Then you're going to square it. And we continue with AB equals square root and we have 5 minus 0, that's 5 squared. So that'll be 25. And then we have 7 minus minus 4. That will become 7 plus 4, which is 11 squared. That will be another 121. So again, we have 25 and added to 121, that's 146. So again, we have another square root of 146. AB is equal to the square root of 146. So this is equal, AB is another square root of 146. So that means AD is equal to AB, okay? And so we can write it on top. We can put it here. AB is equal to a square root of 146. Okay, this is square root of 146 there. All right, so that means AD is equal to AB, and this is AB there. Okay, now these two sides that are marked red are equal. Okay, so we can now put some markings there. Okay, this side is equal to this side. They are equal. Now let's go to the remaining two sides, okay, and determine the distances or lengths, okay. All right, we shall make use of the distance CD or DC, whatever name you want to call it, okay. Both directions will give the same distances. All right, let's compute, say, CD, okay. Let's compute CD. All right, let me erase our previous computations because we will be needing the spaces. Okay, so let's erase this part. And we will be making use of another set of points. We can now erase this. All right, let's make use of C and D. Let's put C here. C is -5, -3. And the other point we need is the D that has the coordinates -6 and +2 there. Okay. All right. Now we shall make use of the difference and then squared plus difference then squared. Or we shall write the formula first. All right. Okay. Let's make use of the formula. All right. We're after CD, and this is equivalent to the square root. Okay. And our formula must be x of C minus x of D. X of C minus x of D. So it will be like this. X of C minus x of D. And then we shall square that. We shall square it over here. And then we have the plus. And then we shall use now y of C minus y of D there. And then we will square it again. Okay, this is the distance formula. This is the distance formula there. Okay, so we're actually using distance here, using distances there. All right, so let's compute CD first. CD is equal to square root. We shall compute one side at a time. Okay, so we can accommodate all the four. All right, x of C minus x of D. All right, that should be like -5 minus -6. Okay, -5 minus -6. And then we shall square that. And then plus, make use of plus, and then y of C minus y of D. That will be -3 minus 2. -3 minus 2, and then we shall square that. There, okay? So the difference of y, that's a -3 minus the +2. All right, let's simplify. CD is equal to the square root. This will now be square root. Okay, we have -5 minus -6. That will become -5 plus 6. So that will only give us a +1 and then squared. So this we will have 1 squared. 1 and then squared. And then we continue with plus. How about -3 minus 2? That's a -5 squared. So we shall have -5 squared. That will still be a +25 later, okay? All right, so we have for CD, CD is equal to the square root, and we have here 1. This will be 1 plus 25 there. And it looks like we have square root of 26. So this is CD is equal to a square root of 26. All right, let's put that. This will now be a square root of 26. There, okay? So that will not be exact, okay? So we will write it as is. CD is square root of 26. We'll put it on top over here. So CD is equal to a square root of 26. So this will be square root of 26. There. All right. Now we'll be doing the, where is this CD first? Okay, this CD, I'll mark it red over here. There. Okay. And that length is square root of 26. That'll be 5 plus. Okay, 5 point something. Okay, it will go over 5 because square root of 25 is exact 5. This is 26. Square root of 26 will be more than 5. Okay. All right. Let's compute for the fourth and final side. Okay, let's find out if it's also square root of 26. If it's square root of 26 also, then we have the other two sides congruent, and this is really a kite. Okay, all right, now let's erase our computations here. Let's erase this part. Okay, and we're going to use now C and B. So let's remove, let's have the pair. Point C is again -5, -3 there. And we have the other point B, which is 0, -4. These are the coordinates. All right. We shall use these coordinates and compute for the distance CB or BC. Okay. All right. So let's compute. So this time we have use distance again, use distances, and we shall have the formula CB. Make that B. All right. So this will now be square root. Okay, we have to compute all the distances and then show which pair are equal. Okay, all right. So we have the formula x. This will now be x of c minus x of b. And then we shall square that. And then continue with plus. We have y of c minus y of b there. And then we will also square the difference. And here's our distance formula. Let's put the numbers. We shall have the numbers right here. CB is equal to square root all right, square root of xc minus xb. That means -5 minus 0. Okay, -5 minus 0. -5 minus 0, and then we square it. This will be squared, and then plus, and then we have y of c minus y of b. So that means -3 minus -4. So this will continue -3 minus the -4 there. And we shall square this like that. All right, so let's continue and simplify. CB is equal to square root, and we have something like, okay, let's simplify the numbers inside the parentheses. -5 minus 0 is just -5. Squaring a -5 gives a positive 25. So we shall have a positive 25 over here. To be added to, okay, what is -3 minus -4? That will become -3 plus 4, and we will have a difference of 1, positive 1 squared. So 1 squared is 1 times 1, which is just 1. And we have again a 26 here, square root of 26. And so CB is equal to a square root of 26. So this is square root of 26. There, okay? All right, so we have our fourth and final distance, CB, which is equivalent to square root of 26. And we have completed the distance computations. And this CB, which is also square root of 26, is the fourth, okay, over here, there. And so we can conclude, okay, this distance is also equal to this distance, there, okay? So what's the meaning of this? Okay, these two sides are equal, and these two sides are equal, but these two are different. different values. Okay, therefore this is a kite. Okay, so therefore this is a kite. Okay, and let us see what answer the computer displays. All right, there. Okay, computer displays this. AB equals AD equals square root of 146. BC equals DC is equal to square root of 26. Okay, don't worry about that BC. BC and CB are just two names of the same side. Also, DC and CD are just two names of the same side. Okay, all right. So at least we have the same computation, square root of 146 and square root of 26. And that's how to prove the quadrilateral is a kite. All right, let's continue with the fifth number. Let's clear the screen and proceed to number 5. I hope this is clear. So this is the way to do it. Use distances between 2 points, okay, and compare the measurements. All right, and if you find one pair equal, the other pair equal, then it's a kite. Okay. All right, so that's it. Let's continue with the next. Let's have number 5. Here's number 5 question. For the quadrilateral JKLM with vertices J, -3, -4, K, -1, 1, L, 4, 3, M, 2, -2, prove that it's a rhombus. What is a rhombus first? A rhombus is another parallelogram, but all the sides are equal in measurement. Okay, so a square has all the sides equal also in measurement. So a square is also a rhombus. Okay, a square is also a rhombus, but not all rhombuses are squares. Okay, all right. All squares are rhombuses, but not all rhombuses are squares. Okay, all right. So um, a square is just a subset of a rhombus. Okay, it's a special rhombus. The corners are 90 degrees. That's a square. All right. So if a quadrilateral has all four sides equal in measurement, then it must be a rhombus. All right. So how are we going to prove this figure is a rhombus? All right. Again, we have four sides. All we need to do compute the lengths of each. If we find all of them equal to each other, then it's a rhombus. Okay, all right, so let's do it. All right, where is point J first? Where is point J? It's -3, -4. It must be here. This must be the J, and this is -3, -4. All right, and then where is K? K must be the one over here. This is K. There, okay? And the coordinates will be -1, 1. This is -1 and 1. There, okay? All right, that's point K. Let me rewrite the point, okay? Let me rewrite that. I think they overlap. They overlap. Okay, this is K. Let me retype the coordinates. Let me put it farther away. It's -1, 1. All right, I hope it's fixed. All right, there. It looks it looks more better than the previous point. All right, let's have the next point, 4, 3. That must be point L. This is 4, 3 at the first quadrant. And then the fourth and final corner, that's 2, -2 at the fourth quadrant. It must be this M. And this is +2 with a -2 Y value. And we were able to place the labels for each vertices, for each vertex. We shall now prove that it's a rhombus. All right, let's compute first the distance say LM, okay? All right, LM. LM is equal to the square root. Okay, let's try to write smaller. And yes, let's do it over here. Okay, we now have x of L. We shall now have x of L. Let's put the L lower. All right, let's put L there. XL minus XM. Okay, this will now be XM. So I'm trying to put the subscripts. So this is XM. And then we shall square this. So this will be squared. All right, let's put the 2 over there. Okay, this is XL minus XM. And then we have plus. This will now be X. We are now using the Y. All right, YL minus YM. Okay, minus YM. So this will be Y and then M. And then we shall close and then square it. And then we shall extend this. Okay, like that. So you see, it's not simple to type the formula here. All right, but I'm trying my best to type with the subscripts. All right, so XL minus XM squared plus Y of L minus YM squared. All right, so let's use the numbers. We shall have the numbers. All right, I hope you can follow the numbers. Okay, X of L minus X of M. Okay, just look at the diagram with the numbers. XL minus XM must be 4 minus 2. Okay, so that will be 4 minus 2. And then we shall square that. We will put the square root later. All right, and then this will continue with the plus. Next is YL minus YM. We are now in the Y values. That will be 3 minus negative 2. Okay, that will be a positive 3 minus negative 2. And we shall square this. There, okay? And then we put the square root sign. There, okay? There. All right, and so we continue with LM, and this is equals. All right, let's simplify the numbers. 4 minus 2, that's 2. 2 squared is 4, okay? All right, I will do a shortcut there. All right, so we can write more. All right, plus, next, 3 minus negative 2. That becomes 3 plus 2, okay? That gives 5, and then 5 squared is 25. And we have here the square root of 4 plus 25, which is simply 29, okay? So this is square root of 29, okay? All right, so this is LM. LM is equal to square root of 29. All right, let me complete. Square root of 29 there. There, okay? All right, let's locate LM. Of course, we shall mark it. All right, it's this. There is LM, okay? I marked it red. All right, let's continue with the next. Let's continue with MJ. Let's continue with MJ. All right, here's MJ. MJ is equal to, let's have the formula first. This will be something like, okay, let's elongate that. And we shall have XM. This will be XM. Let's put the M somewhere here. And then minus This will be xm minus, all right, xj, okay, x, and then with a j subscript, and then close parenthesis, and then squared. We shall put the 2 there. All right. There's the first difference, and then squared, and then put a plus, followed by open parenthesis. We're now using the y. Okay. Let's put the y first. Y, and then minus another y, and then we'll put m and j. Okay. Let's put here m, and then j. All right. Okay. And then we shall close, and then squared. Close, and then squared. There. Okay, so here's the formula for mj. All right, the formula for mj. So this will now be mj is equal to a square root. Okay, let's now use the numbers xm minus xj. That'll be 2 minus negative 3. Just look at the numbers in the diagram. Xm is 2, minus xj is negative 3. So it's minus the negative 3. And then we shall square that later. All right, we'll go back there later. All right, y of m is negative 2 minus negative 4. Okay, there. And then we shall square this. This will now be squared. And then over here will also be squared. There. All right, so next, continue with mj. Let's do a shortcut there. 2 minus negative 3, that becomes 2 plus 3. All right, minus minus, that becomes plus. So 2 plus 3 is 5. 5 squared is 25. So this will be a 25. And then we add. All right, let's go to the next. Negative 2 minus minus 4, that becomes negative 2 plus 4. And so a difference of positive 2. And then positive 2 squared is a 4. And so we have another 29 under the square root. So this will now be square root of 29. So mj is another square root of 29. Okay, this is another square root of 29. There. Okay. All right. So we have two sides, square root of 29. So we have again another side over here. I'll mark it red in the diagram. This is another square root of 29. Okay. All right. Let's continue with the next distance. All right. Let's have the next. Let's compute jk. All right, jk. We shall try to accommodate all the distances over here. Let's use this portion. I hope it fits. Let's put a fence there. Okay, hope we can write more. All right, let's continue with the next. All right, let's continue with the next. This will now be jk. jk is equal to the square root. Let's use the straight. All right, this will now be a square root. All right, let's write the formula. This time we're dealing with point j and k. So xj, let's put the x first. Minus, and let's put a minus and another x. All right, and then close, and then plus, parenthesis, and then y minus y, and then close. All right, let's put the subscripts now. This will be xj minus xk. All right. All right. Okay, there. All right. Now the other one is also yj minus yk. There. Okay. All right. And then we will have to square this. There must be a 2 over here. and 2 over there. I hope it fits. All right, of course, that's it. All right, so I hope you can read it. Xj minus xk squared plus yj minus yk squared. All right, let's put the numbers. Jk is equal to square root. This will now be like this. And let's put the numbers. Okay, what about the numbers? All right, xj minus xk. Look at the drawing with the numbers. Xj is -3, okay, and xk is -1. And so we will have -3 minus -1. And then we shall square that later. All right, and this will now be, next is yj. Yj is -4 minus +1. Okay, minus +1. And this will now be squared. All right, let's put the number 2's. All right, there's a number 2 there, and we have a number 2 here. All right, there. Okay, let's continue with the computation. Jk is equal to square root. This will now be square root. Okay, -3 minus negative, that will become -3 plus 1. So that results to -2. -2 squared is a +4. So this will be a +4. Okay, there. And then plus, okay, -4 minus 1 is a -5. -5 squared is a +25. There. And so this is another 29. Okay, square root of 29. So we have here square root of 29. And so this is our third side. This is our third side, and they are all equal so far. All right, square root of 29, square root of 29, square root of 29. And we're talking about this side over here that I will mark red there. Now, the fourth and final side, uh, LK or KL, whichever direction you like, we shall try to figure out the distance, the fourth side, all right? Now, let's just make use of LK, all right? And I'll write it over here, okay? Exactly the remaining space over here. LK is equal to the square root of, we shall put the square root symbol. All right, right there. Okay, and the formula. Okay, all right, let's put the formula. Excuse my typing, all right, because this does not contain how to put a subscript. So I'm trying to just move the text back so I can put the subscripts and superscripts. All right, so this will now be XL. So let me put the X first, and then a minus and X, and then close parentheses, and then I'll put a plus there, and parentheses and Y, and then minus Y and parentheses, and then let's put the subscripts now. All right, so we shall have here XL, and then that will be K. This must be K. I hope it fits right there. That doesn't look nice. Let me rewrite it again. Let me just rewrite it again. That should be LK, okay? So this will be L, and this must be K, and then this must be L, and this must be K. All right, there. Okay, and then this will be squared, and over here will be another squared. Okay, there. All right, so I hope you can see it clearly. All right, that's YL minus YK squared. All right, I hope you can just adjust it later with your own handwriting. All right, let's put the numbers. LK is equal to XL is 4, okay, minus XK. So it's 4 minus -1. Okay, so this will be 4 minus -1, and then we have plus, and then y of L minus y of K. That looks like 3 minus 1. Okay, they are both positive, and then we shall square this. We put a number 2 right here and a number 2 over there, and then we shall put the square root sign there. Okay, all right, and so we shall simplify the numbers. We shall simplify the numbers. This will be LK is equal to okay, 4 minus -1. That will become 4 plus 1, which is 5. 5 squared is 25. And then this will continue with 3 minus 1. All right, that looks like 2. 3 minus 1, 2, and then square that, that's a 4. And so we have another 29. Okay, all right, so this will now be square root of 29. Okay, 25 and 4 added together, that should be, of course, square root of 29 again. And we have all four sides square root of 29. Okay, and that goes to show it's a rhombus. Okay, all sides equal in measure, it's a rhombus. Okay, there. Okay, and we were able to show that all four sides are equal in measurement, and this is the fourth and final side. I'm marking it red there. That means all those four sides measures square root of 29, and we can verify that from the computer. That's LM equals JK equals MJ equals LK. Okay, there. We shall shrink it, and you can see the answer there, blinking there. All right, square root of 29. It's overlapping with our own handwriting. Okay, we shall shrink it, and you'll be able to see it clearly. All right, don't mind the diagram because it will move there. Okay, all right, there. And our own drawing in the diagram is not matching with the computer's drawing, but I can show you the answer right here. There, okay? You can see it clearly right here, there. JK equals square root of 29, KL square root of 29, LM square root of 29, MJ is square root of 29. So all the four sides have equal measures, and that means it's a rhombus, okay? All right, so that goes to our number 5. Let's continue with number 6. Let me clear the screen. Number 6, and then we shall make it larger. All right, there. Okay. All right. Okay, what do we have here? For the isosceles triangle ABC, we with vertices at A, -4, 7. Where's -4, 7? That must be over here. Second quadrant. This must be -4, 7. A is -4, 7. There. Okay. All right. Next. B is 4, 1. So it must be in the first quadrant. It's over here. This must be our B 4, 1. There. And then the third point of the triangle, C, it must be the 2, -1. That should be at the fourth quadrant over here. This is 2, -1. There. Okay. All right. There. All right. So find its perimeter. Okay. Meaning to say, get all the three distances and then add all of them. All right. And that should be it. All right. So let's compute the distance AB and then BC and then AC, and that's it. We add all of them and we get the perimeter. All right, so let's do it. This will be our solution. Let's start with AB. All right, let's start with AB, and this is the formula. we have xa minus xb, and then squared plus ya minus yb squared. Okay, I'll put the subscripts later. All right, so this will now be under the square root sign. Okay, so this will be AB. This will have A, and then this will be having the B. And this will have the A, and this will have the B. Okay, there. All right, looks okay. And then this will be squared, and this will be squared there. All right, so there. Okay, looks more like the right formula. XA minus XB squared plus YA minus YB squared. Okay, the distance formula. All right, let's put the numbers. We have AB is equal to, that will be open parenthesis, XA minus XB. That's -4 minus 4. Okay, that's -4 minus 4, and then we will square it later. Let's proceed to YA, that's 7, minus YB, that's 1. And then we shall square it. This is squared. This is also squared. And then we put the square root symbol there. And then let's compute. Let's have the computation for AB. This is -4 minus 4, that's a -8. And then we shall square that. Shall we do a shortcut? All right, -8 squared, that's positive 64. And then plus 7 minus 1, that's 6. 6 squared is 36. All right, and so we will add 64 and 36, which is exactly 100. All right, 64 and 36, it's 100. We have square root of 100. AB is square root of 100, and that's exactly 10, okay? All right, so we have 10 units there, all right? I did a shortcut there, but it's okay. You can add them later. 64 and 36 is 100. Square root of 100 is just 10. Okay. Let's continue with AC. All right, AC, and we shall put it, say, at the bottom. All right, let's put AC. This is a different side now. AC is equal to square root. Let's start with the inside. All right, we shall have XA minus XC. All right, it's prayer time. I'll do that later. All right, so this will be plus. All right, we have y of A minus y of C, and then squared. Okay. All right, so this will now be square root, and this will now be squared, and then this will also be squared. Okay, this is AC, so we put a subscript A, and then we put another over here, B. All right, okay, shall we do it again? Well, it's understandable. All right, let's do it again, because it's supposed to be AC. Okay, it's supposed to be AC. All right, let me clear that. All right, let's start again with A. This is A, and then this must be C. All right, and then over here will be another A and another C. All right, I hope it's there correctly. Well, okay, that's it. Now let's use the numbers. We shall have now the numbers. This will be, of course, x of A is -4. minus x of c is just 2. Okay, so negative 4 minus 2, and then we will square that later. We shall proceed to y of a, which is 7, minus y of c, and y of c is just negative 1. So after the minus in the formula, we put a negative 1. All right, now we square it. 2, and then 2, and then put the square root sign. This will now have a square root symbol right there. All right, let's continue. This will now be AC. This is equal to, what is negative 4 minus 2? It's a negative 6. Negative 6 squared is a positive 36. And then 7 minus negative 1, that becomes 7 plus 1, that's 8. 8 squared is 64. And again, we have 36 added 64 is 100. And so again, we will have square root of 36 plus 64, which is another square root of 100. That should be exactly 10 units. So AC is 10. AC is equal to 10. All right, there. Now for the third and final side, which can very well accommodated in our right side of the screen. Let's just put it here. This will now be the shortest side, BC. And it really looks like an isosceles triangle because AB is 10, AC is also 10. So two sides equal makes an isosceles triangle. Now let's compute the shortest side, BC. In the drawing, it looks like the shortest. Okay, all right. And so we shall have the formula first. This will have, let me just type it first. This will now be BC. We're doing BC x of B minus x of C. And then we square it plus y of B minus y of C. And then we shall put the labels first. This will have B and C, okay? B, C, B, C, there. Okay, there, exactly where we want it to be placed. All right, so this will now be squared. Okay, we shall put a number 2 here and a number 2 over there. Okay, and then put a square root. Okay, here's our third formula. Let's put the numbers for side BC. All right, this will now be XB minus XC. All right, that'll be 4 minus 2. 4 minus 2, and then square later. All right, for YB minus YC, that'll be 1 minus negative 1. 1 minus negative 1, there. And then we shall square each of this group, and then each of these, yes. And then this will now be square root. All right, this will now be it. We continue with BC. This will now be BC is equal to, all right, let's get 4 minus 2 squared. That's 2 squared, which is just 4. And then 1 minus negative 1 is 1 plus 1, which is 2. 2 squared is another 4. So we have here a square root of 4 plus 4. And so this is square root of 8. All right. So this will now be like square root of 8. We have here 8. And then we have the square root. This shall have a square root symbol. Now, square root of 8 can be simplified. That's square root of 2 times 4. And that means 2 square root of 2, okay? And this will be 2 square root of 2 there. So we'll put a square root sign there, okay? I hope you were able to get that. I'll show you. Square root of 8 is square root of 4 times 2, like that, which is equal to square root of 4. You can split this to 2 square roots there. And square root of 4 is an integer. So this will be 2 times the square root of 2 there. Okay? And so we're going to add 10 plus 10 plus 2 square root of 2. So we have for our answer, that should be about 20 plus 2 square root of 2. So it must be our perimeter, okay? So our perimeter, let's try to put it here. Perimeter must be equal to 20 equals 20 plus 2 square root of 2 there. And we shall put the square root sign. There. This must be the answer. 10 plus 10 plus 2 square root of 2. Okay, all right, let's check and verify the answer from our computer over here. There, okay, exactly like our answer. All right, there. Okay, so that goes to our number 6. Let's continue with the next number 7. Let me clear the solution, clear the answer. And this is number 7. All right, for the triangle RST with vertices at R negative 7, 1. Where is negative 7, 1? Is at second quadrant. Okay, so this will be R over here. So this is R, which is negative 7, 1. And where is S? That's 5, 6 at the first quadrant. So it must be this. And this is 5, 6 there. And then our third and final point T, also in the first quadrant, which just over here. So this is T, coordinates 2, 2. And there, okay? Find its perimeter. So compute the 3 sides, add them together, you get the perimeter, okay? Let's compute. All right, our solution will be, let's start with RS, okay? RS. And we shall have XR minus XS. I'll put the subscripts later. All right, so this will be plus, and then we have Y R minus YS, okay? And then we shall square it. All right, I'm talking about the subscripts over here. So this will now be R, and then S, and then R, and then S. There, I hope it fits there. There, XR minus X, S, YR minus YS. And then we shall put the squares. This will be squared, and then squared. And then we put the square root symbol. These are supposed to be inside the square root. This is the distance formula. All right. This goes to our first distance, RS. Let's put the numbers. This will now be XR. XR is negative 7 minus XS. That looks like a positive 5. And then we square it later. All right, let's continue with YR. YR is 1 minus ys, that's a 6. Okay, and then we shall square this. So let's put the number 2. Number 2's here. All right, this must have number 2 and then another over there. All right, and then we shall put the square root symbol. Okay, there. All right, so we have -7, -5. It's a -12. When you square a -12, that will still be positive 144. Okay, so this will be RS, and we have 144 plus 1 minus 6 is a difference of -5. Squaring that, it's a -5 squared is a positive 25. So 144 plus 25, that looks more like 169. So this is 169. We have a square root of 169. So this is now RS, which is 169 under the square root symbol, which is just 13. Okay, so this will just be equals 13 units, and that's the side over here. RS is, let me put a red mark there. Okay, that's RS, and that measures 13. All right, let's continue with the next side. Let's proceed to the next size, RT. Okay, that looks more like in between the shortest and the longest. Let's compute RT. RT is equal to, let's put the formulas first. This will be XR minus XT plus YR minus YT. And then we square that. Let's put the subscripts first. This will now be R, and then T, R, and then T. Right there, exactly where we want it. And then we put a number 2 here. We put a 2 and another one over here for the squared. All right, so this will be under the square root symbol. This gives us the distance formula from point R to point T. All right, let's continue with the numbers. RT is equal XR minus XT. All right, that should be -7 minus 2. -7 minus 2. And then plus, let's have YR minus YT. YR is 1 minus YT, that's 1 minus 2. So 1 minus 2, and then this will now be both squared. So you put a number 2 here, and then over here. All right. Okay, and then the square root symbol. Okay, let us simplify. -7 minus 2 is a -9. -9 squared is a positive 81. So we shall have a number 81 there. RT is equal to 81. How about the 1 minus 2? 1 minus 2 is -1 result. -1 squared is a positive 1. And so we have 81 plus 1, that's 82. A square root of 82 for the next size. So this will be square root of 82. All right, this is our second length. This is square root of 82. All right, so let's put the square root symbol for our distance RT. Now we're doing the third side. Let me put a mark there. Let's put a mark for RT. Okay, I'm shading with a red color the side we just completed there. All right, we're now on the third side. Let's compute ST. Okay, this is distance ST. Here's the formula. Let's put a fence over here. And we're doing now the side ST, the third and final side. ST is equal to XS minus XT, and then we square that later, and then this will be YS minus YT. All right, let me put the subscripts S and T. This we have the S, and then followed by T. Let's put capital letters S, and then T, and then S, and then T. All right, and then we shall square it. We shall have 2 over here and 2 over there. And we put the square root symbol, and this completes our formula for the third side. All right, over there. All right, let's continue with ST. ST is equal to XS. All right, that should be 5 minus 2. That should be XT. And then the other values, YS, that's 6, minus YT, it's 2. All right, there. And then we shall square. This will now be squared. We put the number 2 over here, and then another over there. And then the square roots. All right, let's simplify the numbers. We shall have 5 minus 2, that's 3. So we have 3. 3 squared is 9. Okay, 3 squared is, yes, let me do a shortcut. 5 minus 2, 3. 3 squared is 9. There. And then we have 6 minus 2, that's 4. 4 squared is 16. So we have 9 plus 16, okay? And we have a 25. All right, so ST, this is now ST, which is square root of 25, okay? Which is exactly 5 units. And this is just 5, okay? All right, so we will just put here equals 5 units. All right, let us now add for the perimeter. This is now for the perimeter. For the perimeter. We're asked to get the perimeter, okay? And we shall have P is equal to 13, okay, plus 5 plus square root of 82, okay? So this will be 82, let's put 82 and then the square root. All right, so we put there 82, and then we put the square root symbol. There, okay? Looks like 18 plus square root of 82. So this is our answer. P is equal to 18 plus 82 square root. All right. There. And this is now our answer. Okay. So this is 18 plus square root of 82 units. There. All right. So this is our final answer for number 7. There. Okay. All right. And I shall put a red mark. That's the shortest, which is the 5. Okay. All right. So that's the shortest. The shortest is the 5. RT is of course 9 something. Okay. It's more than 9 because 81 is 81 squared, or square root of 81 is exactly 9, but this is square root of 82. So it's 9 something, and that's greater than 5. So the smallest side is 5, the longest side is 13, the middle value is 9 something, okay? So this is about plus 9, so it's more like 27 point something, okay, in decimals. All right, let's have the exact answer from the computer. Okay, so it's 18 plus square root of 82 units over here. Below the drawing, you can see the answer from the computer's database there. All right, so I hope you were able to see our solution. Okay, and let's continue with our number 8. All right, let's clear the screen for number 7. Let's remove the answer. And then number 8 now. All right, here's number 8. Find the perimeter of the trapezoid WXYZ with vertices at W, negative 5, 3, X, 2, 3, Y, Z, this is Y is 7, negative 2, and points Z, negative 6, negative 2. Let's locate the points first, the corners of the trapezoid. All right, where is point W? Negative 5, 3. All right, it looks at the second quadrant over here. W, and this is negative 5, negative 5, 3. There. You can read from the X and Y axis, it's negative 5, positive 3. Point X is at the first quadrant. It's over here. So this is X, that's with coordinates 2 and positive 3. And then for our third point will be point Y at the fourth quadrant. This is our Y with coordinates 7 and negative 2 there. And then for our fourth point, which is Z, it's at the third quadrant. This will be Z. This is with coordinates negative 6, negative 2 there. Okay, all right. Let's now compute the perimeter. And the only way to get that is to compute all distances, all measurements of each side. All right, let's start with WX. Okay, let's compute. We shall have WX. All right, let's put the formula. This is XW minus X, X, and then plus we have YW minus YX. Okay, is it that confusing? All right, a little bit confusing. All right, so this will now be, because we have used the X as name of the point. Okay, all right, so let's have the subscripts. This will be XW, and this will be, of course, X. Okay, and then we shall continue with YW and YX. There, okay? I hope it fits. Okay, let's put more distance there, okay? Let's put more distance because they look very close. All right, let's retype it. All right, WX distance is equal to, all right, let's start with XW minus X of X, and then we have Y of W minus Y of X there. All right, let's put the subscripts. This is W and X. Maybe we shall use small W and X, W and X there. Okay. All right, that will do. And then we put the squares. This is squared, another squared. And then we put the square root symbol, and we have the formula there. Okay. All right. Now let's use the numbers. All right, let's use the numbers now. Wx is equal to, what is xw? That's -5 minus, and then x of point x. That's 2 there. And then we shall square that later. Y of w is 3 minus y of x. That's another 3. Okay, then we square it. This will have 2, and this will have 2. And we will have to put the square root sign. All right, let's compute. This is Wx is equal to, what is -5 minus 2? It's a -7. When you square that, it's a 14.9. Okay? And then plus 3 minus 3 is 0. There. Okay? And so we have a square root of 49 plus 0, which is just square root of 49. And that's exactly 7. Okay? This will just be 7. So we will just put here Wx is equal to 7. 7 units. We continue now with xy. All right? Xy distance. The distance from point X to point Y. All right, so xy is equal to, let's put the formula. Okay, x of x minus x of y. And then we have y of x minus y of y. Okay, all right, I hope you're not confused there. All right, so we put here squared. We put here squared, and then another over there. Now let's put the subscripts. Okay, so this is x of x, and then x of y, x of x, y of x, and y of y. There. All right. Okay, so that's it. And then we have here a square root sign. There. Now let's compute. This will now be, okay, x of point x is 2 minus x of point y, it's a 7. And then let's proceed to y of x, that's a 3 minus y of point y, that's a -2 there. Okay, and then we shall square this. We have 2 and 2, and then we shall put the square root symbol over here. Okay, let's continue. We will have xy is equal to, what is 2 minus 7? It's a -5. -5 squared is a positive 25. All right, 3 minus -2 gives 3 plus 2, which is positive 5. Positive 5 squared is another 25. Okay, all right, so this will have the square root symbol. And we have something like square root of 50. Okay, square root of 50. So this will continue like square root of 50. xy is equal to square root of 50. There. Now we can simplify square root of 50. Okay. All right. How do we simplify square root of 50? I'll show you the right side. Yes, square root of 50. Square root of 50 is square root of 25 times 2. And you can split that into square root of 25 times square root of 2. And square root of 25 is exactly 5. So you have 5 square root of 2. Okay? And so that's 5 square root of 2. That will go to our distance xy. Xy is just 5 square root of 2. And so we put the square root symbol over the number 2 there. Okay, so that goes to our side xy. That's the measurement. Okay, all right. So let me just clear this part. I hope it doesn't bother the other writings. All right. Now let's continue with the next. We shall have 2 more sides. Okay. We shall now compute YZ. Okay. YZ. So this will be over here. YZ is equal to, let's have the formula. XY minus X of Z squared plus you have Y of Y minus Y of Z there. Okay. All right. So we shall put here Y and Z as subscripts. We will have here Y and let me put Z. We should clear it first so I can see it clearly. This will be Y and Z, and this is Y and Z there. All right, and then we put the squares. This will now be 2 and another one over here. There. That makes squares. All right, and this will have a square root symbol. We're in the formula first. All right, let's continue with the numbers. So this will now be YZ is equal to, all right, X of Y. No. Yes. X of Y. Yes. X of Y is 7. A little confusing there. 7 minus X of Z. It's a negative 6. There. Okay. And then we have Y of Y is negative 2 minus Y of Z. Okay. Y of Z is negative 2. There. And so this will be squared. You have here 2 and then 2. There. All right. And then we put this under the square root sign. Okay, let's continue with our computation. This will now be YZ is equal to 7 minus negative 6. It's a 13. Okay, 13 squared. So 13 squared is 169. And then plus negative 2 minus 2, that gives negative 2 plus 2, which is 0. 0 squared, still 0. Okay, and so this is now square root of 169 plus 0. This is just 13. This will be equivalent to 13 there. Now, it's a quadrilateral. We need to, this is a quadrilateral trapezoid. We still have to compute for the fourth side, okay? We still have another side left. So this is just for the YZ, and this is for the WX, and then we still have one more, which is the WZ, okay? All right. let's have the WC for our fourth and final side. WZ, we have XW minus XZ, and then plus we have Y of W minus Y of Z. All right, let's put the subscripts. We now have W and Z, W and Z. There, those are the subscripts for the points. All right, and so this will be, of course, squared. We shall put there 2 and 2 there. And we put the square root symbol. Okay, so that's it. It's overlapping with our fence, but it's okay. We can still understand it. All right, so let's continue with WZ with the numbers. WZ is equal to, what is the x coordinate of the point W? It's -5 minus the x coordinate of point Z. It's -6. And then close parenthesis plus, now the y coordinate of point W, it's 3 minus the y coordinate of point Z, it's -2 there. And so we square it. We shall put here squared and then squared. All right. Now put the square root sign. And then let's compute. Okay, -5 minus -6. That'd be -5 plus 6, which is just +1. +1 squared is 1. Okay, so we have a value 1. There's a 1, and then plus, what is 3 minus -2? That becomes 3 plus 2, it's a 5. So 5 squared, it's 25. And so we have square root of 1 plus 25. I hope you'll be able to follow that later as you see the recording again, okay? And you'll be able to analyze clearer, okay? So this is square root of 26, okay? So this is square root of 26. So you have here WZ. Let's just put it over here. This is just over here. Equals square root of 26. And then we put the square root sign. There, okay? All right, so that should be... All right, let me give a little review on these sides. This is 2, 4, 5, 7. Okay, that's correct. This is 5 square root of 2. All right. And then this will be 2, 4, 6, 8, 10, 12, 13. Do we have a 13? Of course, that's YZ. And then finally, this is, yes, square root of 26. All right, for the perimeter, let's compute the perimeter. This will now be for the perimeter. I hope it fits here in this very tiny space. This will be, all right, 7 plus 5 square root of 2. Okay, and then we put the square root symbol. Okay, we put the square root symbol. And then we add 13. Okay, we add 13. So this is plus 13 and plus square root of 26. All right, let's put the square root on the number 26. Okay, there. And then we can still simplify it. We can add the 7 and the 13. And so our final answer should be perimeter is equal to 20 plus 5 square root of 2 plus square root of 26. All right, I will just be placing the square roots. This will now be square root of 2 and then square root of 26. And this will be unit of length, okay? All right, so this will be the answer. All right, so this will be it. This is for our number 8 answer. Our perimeter is 20 plus 5 square root of 2 plus square root of 26. Okay, all right, let's see the answer by the computer. All right, over there, you can see it below the diagram. The perimeter is 20 plus 5 square root of 2 plus square root of 26 units there. These are the exact algebraic answer. Okay, if you want it in decimals, you can use a calculator. Okay, all right, so this is it. Adding all the four sides gives 20 plus 5 square root of 2 plus square root of 26 units. Okay, just remember there is no negative distance. Okay, when you speak of distance, it must be the absolute value. Okay, all right, so that's it for number 8. I think this is the last number. So see you later for other math topics. All right, see you later.